If you're serving premium content through Cloud CDN without signed URLs or signed cookies, you're basically leaving your front door wide open and hoping nobody walks in. I've seen companies lose thousands in bandwidth costs because their CDN cached videos were being hotlinked across the entire internet.
Hey everyone, welcome back to the Network Ninja CloudCast. I'm really excited about today's topic because I've been trying to figure out how to protect content on CDNs without making users jump through hoops.
That's exactly what we're tackling today. GCP Cloud CDN gives you two powerful tools for content access control: signed URLs and signed cookies, and choosing the wrong one for your use case can either frustrate your users or leave security gaps. Let's break down when to use each.
Okay, so I understand the basic idea of protecting content, but what's the actual problem we're solving here? Can't we just put authentication on our origin server?
Great question. And here's where people get tripped up. When you use Cloud CDN, content gets cached at Google's edge locations globally. If someone gets the direct URL to your cached content, they can access it without ever hitting your origin server. Your authentication logic never runs. I worked with a streaming platform that discovered their paid course videos were being shared on forums because the CDN URLs were completely unprotected.
Oh wow, so the cache basically bypasses all your backend security. That's a pretty big hole.
Exactly. Signed URLs and signed cookies solve this by embedding cryptographic signatures that Cloud CDN validates at the edge before serving content. Think of it like a concert venue. Your origin server is the box office that sells tickets, but Cloud CDN is the actual venue entrance. Without signed URLs or cookies, anyone who knows the door location can walk right in. The signature is like a ticket with a holographic seal that security checks before letting you through.
That analogy makes sense. So the CDN itself is doing the verification, not my backend. But what's the difference between signed URLs and signed cookies?
This is the critical decision point. Signed URLs embed the signature directly in the URL itself. You generate a URL like your cdn.example.com/video.mp4, then append query parameters including expires, key name, and signature. Now here's an important nuance. Signed URLs can work with either exact paths or URL prefixes. With an exact path, each URL works for one specific resource. With a URL prefix, a single signed URL can authorize access to multiple resources under that path. Signed cookies use a single HTTP cookie named exactly Cloud CDN cookie that contains the URL prefix, expiration, key name, and signature in a specific format with colons separating each component.
So if I have a single file download, signed URL with an exact path makes sense. But what if I'm serving an entire video course with hundreds of segments?
You've hit the exact use case where you need prefix-based authorization. HLS and Dash streaming protocols break videos into hundreds of small segment files. You have two options here: signed URLs with a URL prefix, or signed cookies. Both can authorize access to an entire path like /courses/course123/*. The main difference is delivery mechanism. With signed URL prefixes, the authorization is in the URL parameter. With signed cookies, you set the Cloud CDN cookie once and it gets sent automatically with every request in the cookie header. For streaming, cookies are often cleaner because your video player doesn't need to handle special URL parameters.
That makes sense. What about the actual implementation? How do I generate these signatures?
First, you need to create a signing key, and this is important. You generate the key yourself. GCP doesn't create it for you. You need to generate a 128-bit, that's 16 bytes, cryptographically random key. On Linux or Mac, you can run head-c16/dev/your-random-pipe-base64 to create one. Then you upload that base64 encoded key to Cloud CDN along with a key name you choose. You can do this in the console under your backend service or backend buckets Cloud CDN section, but for production environments, I recommend using the gcloud CLI with commands like gcloud compute backend services add signed URL key or gcloud compute backend buckets add signed URL key. CLI methods are better for automation and auditability.
Got it. So I'm responsible for generating and securing that key material. What about actually creating the signatures?
For the signature itself, you compute an HMAC SHA-1 over specific content using your key. What you sign depends on your approach. For signed URLs with an exact path, you sign the full URL including the HTTPS prefix and all query parameters up to the signature parameter. For URL prefixes, whether you're using signed URL prefixes or signed cookies, you sign a string in the format URL prefix equals base64 encoded prefix ampersand expires equals timestamp ampersand keyname equals your keyname. The exact format matters here. GCP provides code samples in their official documentation that show how to construct these using standard cryptographic libraries like Python's HMAC and HashLib modules, or the cryptography library. There's no dedicated high-level Cloud CDN signing function in the client libraries, so you'll be working with those code samples directly.
Wait, HMAC SHA-1? Isn't SHA-1 considered weak these days?
Good catch, and this is important context. For HMAC operations, SHA-1 is still considered secure because the attack vectors against raw SHA-1 don't apply to HMAC constructions. Google's documentation confirms this is the required algorithm for Cloud CDN signing. You can't substitute SHA-256 here. The security comes from keeping your signing key secret and setting appropriate expiration times.
Got it. What about expiration? How long should these signatures be valid?
This is where I see the most mistakes. People either set expirations too long, creating security risks, or too short, breaking user experience. For signed URLs on downloadable files, I recommend 5 to 15 minutes, enough time to start the download but not long enough to share widely. For signed cookies on streaming content, match your session duration, typically 2 to 24 hours depending on your use case. Never set expiration to days or weeks unless you have a specific reason.
What's the biggest mistake you see teams make with this?
2 things. First, storing the signing key in their application code or Git repository. That key should be in Secret Manager or your secrets management system, never hard-coded. Remember, you generated that key, so you're fully responsible for protecting it. Second, forgetting to enable signed request enforcement on the CDN configuration itself. You can generate signed URLs all day, but if the backend service doesn't require signed requests, unsigned requests still work. Look for the signed request settings in your Cloud CDN configuration. The exact label may vary in the console interface, or configure it via the API using fields like signed URL cache max AgeSec. People miss this constantly.
Let me make sure I've got this. Signed URLs can work with exact paths for single resources, or with URL prefixes for multiple resources under a path. Signed cookies use the Cloud CDN cookie with a specific colon-separated format to authorize path prefixes. The choice between signed URL prefixes and signed cookies is mainly about delivery mechanism. I generate my own signing key and upload it to GCP. Both require enabling enforcement on the CDN backend, and the signing key must be kept secret.
Perfect summary. 1 pro tip: test your implementation by trying to access content without the signature. If it works, your enforcement isn't configured correctly. Always verify the negative case.
This is super practical. I'm definitely implementing signed cookies for our video platform this week.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone building content delivery systems on GCP.
Thanks for watching the Network Ninja CloudCast. See you in the next one.